Ladies and gentlemen, greetings. It's a great honor to be here at the International Conference on Computer Vision. I'm from the School of Computer Science and Software at Shenzhen University in China. My name is Qingyuan Zhang. The title of my talk today is Breaking Rectangular Shackles, Cross-View Object Segmentation for Fine-Grained Object Geolocalization. First, I'll introduce cross-view object geolocalization. Cross-view object geolocalization aims to find the geographic location of a specific object in the query image by matching it to the reference image with attached geographic information. The main contributions of this paper can be summarized as follows. First, we propose a cross-view object segmentation scheme to reformulate cross-view object geolocalization, which uses segmentation masks to define irregular cross-view objects for fine-grained object geolocalization. Second, to support this scheme, we create the CVOGL-SEG dataset to provide high-resolution mask annotations for objects. Then, we propose a transformer object geolocalization (TROGO) framework to implement the cross-view object segmentation, which consists of a heterogeneous task training stage HTTS and a SAM prompt stage SBS. Finally, extensive experiments reveal the attractive potential of cross-view object segmentation for fine-grained object geolocalization, and our TROGO achieves state-of-the-art performance. Next, I'll explain the motivation for our work and compare different schemes for solving the cross-view object geolocalization task. The retrieval-based scheme divides the satellite image into uniformly sized patches to construct a reference database and attempts to retrieve the patch that is most semantically similar to the query object as a location proposal. The detection-based scheme finds the best bounding box containing the query object in satellite images as a location proposal. Our segmentation-based scheme attempts to obtain a segmentation mask of the query object as a location proposal. Clearly, the segmentation mask proposal expresses the location of the irregular object more accurately. To support our cross-view object segmentation scheme, we created the CVOGL-SEG dataset based on the CVOGL dataset. It provides pixel-level annotations for each query object. We compared the theoretical baselines achieved by different schemes for fine-grained cross-view object geolocalization. We also compared the best object masks obtained by different strategies. To tackle cross-view object segmentation challenges, we proposed Transformer Object Geolocalization (TROGO), a two-stage framework. First, the heterogeneous task training stage HTTS employs a single transformer encoder with a cross-view object perception module CVOPM and is trained by learning a heterogeneous task. Second, the SAM prompt stage SBS utilizes SAM's zero-shot segmentation capability, guided by HTTS outputs, to generate precise masks. The cross-view object perception module is the core component of TROGO. Human perception provides a key insight. When searching for cross-view object localization cues, observers consciously integrate the object and its semantic context, e.g. road layout, neighboring buildings. Next, we present our experimental results. Rectangular shackles, defining geographic locations of objects using rectangular regions. The CVOGL dataset only provides bounding box B-box annotations, supporting the evaluation of cross-view object geolocalization with rectangular regions as outputs. Comparison with previous works on the CVOGL dataset. Breaking rectangular shackles, defining geographic locations of objects using segmentation masks. The CVOGL-SEG dataset provides segmentation mask annotations of the objects to support cross-view object segmentation. Comparison with previous works on the CVOGL-SEG dataset. Visual comparison with state-of-the-art methods. Click points are indicated by red dots in the query images. Red, green, and blue regions represent ground truth, prediction, and overlapping regions, respectively. To evaluate each component of TROGO, we performed ablation studies on the KVOGL-SEG and KVOGL datasets. Experimental results on both datasets demonstrate the effectiveness of each component. To investigate the impact of different SAM prompts, we provide different external prompts for the SAM prompt stage. We found that using both bounding box and point hints together yields the best performance. Visual comparison on the KVOGL-SEG ground satellite test set further demonstrates the effectiveness of each component. Our summary of this work includes, in this paper, we propose a novel cross-view object segmentation CVOS scheme to break the rectangular shackles of existing retrieval-based and detection-based schemes by predicting pixel-level segmentation masks of query objects for fine-grained geolocalization. We create a new KVOGL-SEG dataset to support and evaluate this scheme. We propose a transformer object geolocalization TROGEO framework, which consists of 2 stages. This study demonstrates the necessity of segmentation masks to represent the geographic location of objects, opening up new possibilities for fine-grained cross-view object geolocalization. Thank you. This concludes my presentation. Welcome to our project homepage. If you have any questions, please contact me via email.